Hi everyone, welcome back to another video. Today we're going to be looking at a couple of formulas that sort of are like the foundation of probability. Addition rule, conditional probability rule, and multiplication rule. And we'll do an example that sort of explains these as well. All right, so let's have a quick sort of look at this. So addition rule firstly, let's have a look at how we'd find the probability of A union B. All right, so A union B. So remember from the last video, if you remember, that's the probability of one or the other happening. So it's those two areas there. And so if we're trying to find that, what we could do is we can add the, I haven't left myself much space there. I just have to write down the second line. The probability of A, all right? So probability of A is that. So that's the sort of the area that represents the probability of A. And what we can do is we can add the probability of B, right? And I'll change colors to black. And that's the probability of B, all right? So that B, you'll see how it overlaps. Because that overlaps with the probability of B, then we've actually counted this area in the middle. We've actually counted that twice. We counted that sort of that region, that distribution of probabilities when we did A and when we did it B. And so to fix this formula up, what we need to do is subtract the probability where they intersect. So remember, A intersect B is that area that goes in between those two. And so that is actually the addition rule there. If you want to find out the probability of A or B, then you add probability to probability of B and then subtract the probability of the intersection. Okay, so that's what's called the addition rule. Let's now have a look at conditional probability. Again, this is one that people find a little bit confusing, which is totally fine. But let's sort of draw it to understand what it is. So what conditional probability and how you read this here, that means probability that A happens given that B has already happened or has happened at the same time or whatever. So given that B has already happened, what's the probability that A will happen? And so let's just have a look again, look at our Venn diagram. So if that's A, and that's B. All right. So let's have a think about how would we find out this probability. Now, given that B has happened, that means that we are inside of B. B's happened, so we are inside of this circle here, that B circle. So that's going to be our bottom line. That's the list of total possible outcomes. I'm just going to do, again, I haven't got much space, but that bottom line is going to be the probability of B. That's the total number of things that could happen. And what's the probability of A given that we're inside of that red area there? Well, that's going to be the only A's that are inside of this circle are those ones in there. Okay, so they're the probability of A, that black stuff there. They're the probability of A given that we're inside of B, given that we've got probability of B. And so the formula, what it ends up being is that intersecting area, the probability of A intersect B. And that is our formula for conditional probability. Just put a box around that one there. Okay, so probability of A given B is equal to the probability of A intersect B divided by the probability of B. That's going back to our the age-old formula to be able to find out that top bit there. That bit is the number of outcomes that we're looking for, and that bit there is the total number of possible outcomes. Okay, so hopefully that makes sense. That's conditional probability, A given B. And remember, given B means that B has already happened or is assured to happen. Okay, and last rule that we're going to look at today is the multiplication rule. Okay, so we found the addition rule was about finding the probability of A union B. This one's about finding A intersect B. And if we look back at the conditional rule formula, what we can do is we can rearrange that, all right? So if we rearrange that formula, we can do probability of A intersect B is equal to probability of A given B times by probability B. Okay, so that's just purely just rearranging conditional probability around a little bit. Okay, and so that's our multiplication rule. So I'll just put a box around that. Okay, so that's really important rule. So that's how we would find A intersect B, the probability of A intersect B. But there's an even better result that comes from this, which is good. And so that wasn't very well explained, which is when this situation comes up, it makes our lives much easier. And so just thinking about A and B, okay, let's just have a look at this sort of center bit here. The probability of A given B. Now, if A and B are independent events, in other words, if the probability of A happening has no effect on the probability of B happening and vice versa, then that means that the probability of A intersect B, A given B is that bit there that I've just highlighted, that will just be equal to the probability of A, because B has no effect on A, so that is just the probability of A. And so what that means is that if they're independent, just get rid of all that crap, if they're independent, if A and B are independent, then we get a special result, which is probability of A intersect B is equal to the probability of A. That's that bit there. Remember, that will just be the probability of A times by the probability of B. So we can just multiply probabilities together if they're independent. That's a big if. So you have to make sure, if you're going to be using that rule, make sure you have confirmed that they're independent. And so that there is the multiplication rule. Very, very good. Let's go and crack open an example. Okay, so let's have a look at this. Probability of A is 0.2, probability of B is 0.36, probability of A intersect B is 0.16. So find the probability of A, so my pen just stopped working, A union B. Remember, that's equal to the probability of A plus the probability of B. But when we add those two together, we have already counted the intersection twice, so we need to subtract the intersection of A and B. That's equal to probability of A is 0.2, probability of B is 0.36, and the probability of the intersection is 0.16. So what's that equal to? 0.2 plus 0.36. Well, 0.36 minus 0.16 is 0.2, so it's just going to be 0.4. Hopefully I did my maths right. That would be embarrassing if I didn't. That looks fine to me. So 0.4 is the probability of A union B. All good. Let's have a look at the probability of A given B. So let's just write down the formula. The formula is A intersect B, if you remember, divided by probability of B. So let's put it in. A intersect B, what was it? That was 0.16 over probability of B. What was the probability of B? I've lost it, 0.36. And that's it. Nice and easy. So 0.16, I'll just times everything by 100. So 16 over 36. Divide by 4. I'll get 4/9 as my answer for probability of A given B. And lastly, are A and B independent? How do we tell whether they're independent? I should have probably on this formula up here done both ways, because if this is true, if this whole thing here is true, then that means that they're independent. Okay, so that's a test that we can do to see whether two things are independent or not. So let's just check that out. Okay, so let's find probability of A intersect B. We don't have to find it, we've already got it somewhere. It's 0.16, I believe, 0.16. Okay, and let's also find the probability of A times the probability of B. And if this is equal to 0.16, that means they're independent. If it's not equal to 0.16, they're not independent, sorry. So probability of A was 0.2. And probability of B, I keep losing it, 0.36. Okay. 0.2 times 0.36, that'll be a 72. Is it 0.072? I think that's right. That looks right to me. Yep, and so 0.072. And because this is not equal to the probability of A intersect B, Therefore, they are not independent. Because remember, if probability of A intersect B equals the multiplication of probability of A times probability of B, then they are independent. But that is not true, so they are not independent. Hope that makes sense. See you in the next video.